Okay, so I guess I maxed out that video in terms of time, so I know not to do that. I was on this period, which is capital T, which is measured in seconds. Again, it's time it takes for one cycle. Frequency is the number of waves per 1 second. Okay, so this is frequency, lowercase f, is measured in hertz. And to relate period and frequency, capital T is equal to 1 over f, or alternatively, you can write it as frequency equals 1 over t. These are your two main equations here. Okay, compression and rarefaction. A compression is valid for a longitudinal wave. So if I had a slinky and I pushed it forward instead of waving it up and down, if I pushed it forward, you would see areas of high pressure. So a compression is that area of high pressure. High pressure area in a longitudinal wave. Longitudinal, I don't know how to spell this. Let me erase this. Longitudinal wave. Whereas a rarefaction, be careful how you read this. It's called a rarefaction. It's basically all the rest of it. So it's low pressure area in a longitudinal wave. Okay? I want to just go through this really quick. Some equations you'll need are just like we know that velocity is distance over time. This is still the case. Distance in waves is the wavelength and time is the period. Okay? I'm going to show you how to come up with this equation right here. If you know, so if I'm going to rewrite this. I have lambda times 1 over t. That's the same thing as this. Remember that 1 over t is also known as frequency. So here are your two equations. Remember, velocity is always in meters per second. Lambda is in meters. And period time is in seconds. Okay? I'm going to stop there, and I'll see you later.